Hello dear students, welcome to a new algebra session. Today we'll be talking about polynomial functions. In the polynomial functions, let's start by knowing what is a polynomial function. The polynomial function is an algebraic expression such that each of the domain and the codomain of the function belong to the set of real numbers. As you can see here, the definition in front of you on the screen, the function f of x equals a plus a1 times x and so on. So this is called the polynomial function. How can we know the degree of the polynomial function? Each and every polynomial function has a degree. For example, this one, if you have f of x equals a constant, a number like 5, 7, 8, 9, whatever. So this one is called the constant function and its degree is 0. How about this function? F of x equals ax plus b. So what is the power of x here? It's 1, right? Yes. So the degree is 1. So this function is in the first degree, and it's called the linear function. The function f of x equals ax squared plus bx plus c is in the second degree, and it's called the quadratic function. So how do we get the degree? The degree of any polynomial function is the highest power of the variable in the function rule. So in the first one, there was no variable, there is no x, so it has a 0 power. So it has a 0 degree. The second one, ax plus b, the highest power of the variable, which is x, is 1. So it's the first degree. The third one, the highest power of the variable, which is x, is 2. So this is the second degree. Let's go to example 1 and see how can we find the degree of each of the following. If we go to question 1, it says f of x equals 3 minus 2x. You check what is the highest power of the variable. The variable here is written only once, which is the x, and it has a power of 1. So the degree in this case is 1, or this polynomial is in the first degree. For question 2, f of x equals x squared minus x squared minus 3. So in here, don't say that this is the second degree, because you have to write it in the simplest form first. So x squared minus x squared plus 3. If you simplify it more, x squared minus x squared is 0, so this one is equal to 3. So now there is no variable, so this is a constant function. The constant function has a 0 degree. Question 3. F of x equals x multiplied by x minus 2x squared. You distribute it first. So this is x squared minus 2x to the power of 3. So here, what's the highest power of the variable? It's 3. So this polynomial is in the third degree. You can write it as the third degree, or the degree is equal to 3. Last one, number 4. F of x equals x squared multiplied by x minus 3 all squared. So here's the x squared, and then you need to expand this. X squared minus 6x plus 9. We multiply this here, x to the power of 4 minus 6x to the power of 3 plus 9x squared. So in this case, this polynomial is in the fourth degree, or its degree is 4. Let's move on to another example. If f is a polynomial function where f of x equals x squared minus 2x plus 3, find the value of each of the following. F of 1. As you can see here, the question was f of x. The function was f of x. Now it's f of 1. So obviously, we're going to replace each and every x by 1. So here, it will be 1 squared minus 2 times 1 plus 5, and the result will be equal to 4. Question 2. But before solving question 2, please now pause the video, try to answer the coming 3 questions, and then play the video again once you're done. Here in question 2, we're going to replace each x by 2. So it's 2 squared minus 2 times 2 plus 5. If you do your calculations, the answer here will be 5. The same thing will be here, 0 all squared minus 2 times 0 plus 5. It's also equal to 5. And the last one, we replace the x by square root of 3. Square root of 3 all squared minus 2 times the square root of 3 plus 5. If you do your calculations, the answer will be 8 minus 2 square root of 3. Let's move on to a different idea. Example 3. If f of x equals x squared minus 3x and the g of x equals x minus 3, the question here wants you to prove that f of 3 is equal to g of 3. So, first of all, you need to go and find the f of 3. F of 3 equals 3 squared minus 3 times 3. The result here is 0. And you find the g of 3 equals 3 minus 3 equals 0. So here, as you can see, that the f of 3 equals the g of 3, and they both are equal to 0. In example 4, which of the following functions represent a polynomial? Which of these is representing a polynomial? For sure, it is choice. Yes, excellent. It's choice A. Let's move on to the evaluation part. Please, again, as I always tell you, kindly pause the video, go and solve yourself, and then play the video again to check your answers. So here in this question, the question is asking us to find or to mention the degree of each of the following functions. Question A, again, the degree is what? The degree is the highest power of the variable. So this one is the first degree, because the highest power here is 1. Here, you need to simplify it more. So it's x squared minus x squared plus 3. X squared and x squared is 0, so now it's 3. So it's a constant, there is no variable here, so its degree is 0. The degree is 0. Here, if you multiply, you can do it logically, that the x multiplied by the biggest power is x power 3, so it's a third degree. If you want to do it with details, x squared minus 2x power 3, so the degree is the biggest power of the variable, so it's a third degree. And then here, the last question in the upper part is x squared multiplied by x squared minus 6x plus 9. So x to the power of 4 minus 6x to the power of 3 plus 9x squared. So the highest power here is 4, so this is the fourth degree. The next question, the question is asking us to find f of square root of 2 plus 3g of the square root of 2. The functions f and g are written above. So here, in this one, we'll first find f of square root of 2 separately. It's equal to square root of 2 all squared minus 3 square root of 2. So what you will get here is 2 minus 3 square root of 2. To find the g of square root of 2, it's square root of 2 minus 3. Now we're going to find the f of square root of 2 plus 3 times the g of square root of 2. If you do your calculations here, you're going to get the f that we have up, 2 minus 3 square root of 2 plus 3 times square root of 2 minus 3. So here it will be 2 minus 3 root 2 plus 3 root 2 minus 9. If you simplify this, it will be minus 7 because these two are going to be crossed out together. In question B, the question wants us to prove that f of 3 is equal to g of 3 and each of them is equal to 0. So here we're going to go to function f, replace each x by 3. So here the f of 3 equals 3 squared minus 3 times 3, which is 0, and the g of 3 equals 3 minus 3, which is also 0. So f of 3, yes, it's equal to g of 3. Yes, each of them is equal to 0. By now, dear students, we came to the end of our algebra session today. Thank you very much and good luck.